Hello, ladies and gentlemen. Thank you for joining me once again as we continue our look through the 2005 Cayley contest, put out by the University of Waterloo. So here we have question 13. A 400-meter track is constructed so that the points A, B, C, and D divide the track into 4 segments of equal length. The start is halfway between A and B. Andrew begins at the start and walks at a steady rate of 1.4 meters per second in a counterclockwise direction. So he heads this way with the arrow. After exactly 30 minutes, to what point will Andrew be closest? Okay, we've got 5 options: A, B, C, D, or closest to the start. So it's a 400-meter track. Now, the particular shape of sort of a pill doesn't really matter here. Okay, you could have just a giant circle of 400 meters, because A, B, C, and D are just placed so that they divide it. The difference between them is going to be 100 each, other than the start being halfway between A and B. So I'm going to copy this picture. First, get a fresh piece of paper. I'm going to copy this picture, and I'm just going to talk about the distance between them. So we do sort of have a pill shape, so I'm just copying what they have. No, this is B, A, C, D. Okay, so it's 100 in between each of them, because we've got 4 segments, and each segment we are told has the same distance. And then there's the start, which I'm going to abbreviate with S. He's halfway between these guys, so that's 50 meters. Okay. So we start at S, and so the question is, after 30 minutes, where is Andrew? Because if I know how far he's gone around, I should know how close he is to, I can sort of place him on my little map and say, gee, is that close to A, B, C? I can start asking that question. So how far has he walked, or, yeah, walked. I was worried it was a run or a jog. No, it's walk at a steady rate of 1.4 meters per second. How far has he gone after exactly 30 minutes? That should be simple enough to calculate. Distance is speed times time. We're going to have to be a little careful with the units because they say the time is 30 minutes. So he walks 30 minutes times 1.4 meters per second. First thing I got to do is convert them 30 minutes into something with seconds. So that's 30 minutes times 60 seconds per minute times 1.4 meters per second. Okay, now the minutes will cancel out and we'll be all set. So that's 30 times 60, that's 1800 seconds times 1.4 meters per second. Now the seconds will cancel out. 1800 times 1.4. He has walked 2,520 meters, or 2,520 meters. So he's gone around the track a little bit. Every 400 meters, he returns to the start, S. So how many times? So he's gone around several times. So minus, I can see we're going to have 2,400 is a little less than this, but 2,800 is a little bit more. So he's gone around 6 times. So that'll be 120 meters left. So now he's he's looped 6 times, starting again for his 7th run. He goes and he goes 120 meters, so he goes past the 50. But he doesn't quite make it the next 100 because he's got 70 more to go. So he comes around 70. The halfway point between B and C would be 50 meters. He passes that, then he goes 20 more. So he is closer to C than he is to B. So our answer, I believe, is C if they numbered them properly. Yeah. A is A, B is B, C is C. Okay, so C is going to be our answer. Alright, that wraps up question 13 quite nicely. We got question 14 on deck. We'll take a look at that in the next video.